if we have a look to the application example in Dixie, then you see the function group is set in different stages. So that means at first we have the block of the general settings. Here we see the general settings for the maximal transfer duration, manual reset, and so on. We see the readiness check of the functionality. We see the simultaneous sequence functionality, open command, delay command, which needs to be set during the commissioning, and the paralleling sequence. These are the same parameters as we have normally in a synchronous check function. This is the first part of the functionality. The second part is according to the start conditions. And if we have a look here, then we see here have multiple start conditions, as I told before. We have the manual start conditions. We have the fault start conditions. We have, of course, a fault detection. Then we have the under voltage start condition, CB open start condition, and under frequency start condition. And of course, as I told before, you can also add some user-defined start conditions in simultaneous and sequential mode. The next bullet is here in the HSBT function. The next block is the switching types, is according to the switching types. Each switching types can be activated or deactivated separately. You have the fast mode on the top. Then you have the real-time fast mode and the settings for the real-time fast mode, the in-phase mode or synchronous mode. Then we have the residual voltage mode and the long-time mode here. And this can be set separately for each mode. So that means if your application requires only fast mode, real-time fast mode, and in-phase mode, you can switch off the other long time and residual voltage mode. So, and how these functionality is working together. So that means in your project, you instantiate the circuit breakers. In our model, we have 3 circuit breakers, and in each circuit breaker, you will find then the HSBT interface. The HSBT interface is made that the functionality himself, the HSBT function, can act on the circuit breaker. And in the interface, we define the CB make time and the voltage sync ratio when we have a transformer in between and so on. And of course, we also, and this was what I explained before, we also have to define the transfer directions. For each transfer direction, you have to set an own function block for the transfer direction, which contains the information mode on, off, or test, or if it is a manual transfer or an automatic transfer, and which, of course, in our application, which busbar voltage they need to use for it. So, and if we define the transfer, or if we have to define the transfer directions at the end, we have to go to the transfer routing, and this is a special block as well. So, and we keep a lot of effort to create these kind of matrix to have a have a good usability to define these transfer directions here. So, and you can see here on the left side, you see there's a matrix, and for each transfer direction now you can decide which breaker needs to be open, which breaker needs to be closed, and maybe which breaker needs to be considered, for example. And for the first transfer direction, we have here breaker 1 needs to be open, breaker 2 needs to be closed, and the TICB needs to be closed. Otherwise, this transfer direction is not active. On the right-hand side, we see here there is the transfer groups and priority mapping. So when we use that one, maybe for more complex application where we have double busbar, multiple infeeds and so on, therefore we can decide that, okay, we can group these transfer directions and we give them the priority. For example, when this transfer direction 1 is not available, then for the grouping 1, the transfer direction 2 should be work. So this is a very good possibility here in Dixie to do the settings and to do the parameterization for each transfer direction, and offers you a full flexibility. So when we talk about here the different applications, then I have three typical applications here in Dixie available. That means when you start your engineering in Dixie, then you will find here now up to 5 application templates. I think these 3 are the typical ones. On the left side, we have a 2-breaker application. That means 2 incomer and 1 single bus bar. In the middle, we have there are 2 incomer and 1 tie CB in the middle, so that means there's a sectionalized bus bar. And on the right-hand side, we have a typical application for the industry here, where we have a single bus bar with 3 incomers. And everything can be covered by 1 single device. So, and if you start your engineering in Dixie, that means you select in a library your hardware, and you start your example, then you will find here now up to 5 application templates. The other application templates is a double bus bar with 3 incomers, and we have also a new application template, 3 incomers with 2 sectionalized CBs. So, and this is now available with version 9.60. So, and when we, today for the dynamic testing, we select here these typical applications, sectionalized bus bar with 2 incomers. For such an application, we need this hardware, this device here on the table. I have selected 3 FG circuit breakers for it. That means we have to count here the circuit breaker in the application, 2 incomer circuit breaker and 1 tie CB circuit breaker. We have 2 times the current from the incomers, 3-phase currents. We have 2 times the voltage in the inputs, 3-phase from the busbar 1 and busbar 2. And we have 2 times a single phase, face-to-face voltage inputs from the incomer. And this is the minimum requirement for the HSPT system. Now with version, with the next version, with the 9.70, we support also the single phase connection type for the motor bus, for the bus bar. So instead of a 3-phase voltage input. This reduced, of course, in the end, a little bit the hardware, the necessary hardware, and especially for retrofit applications, we will have always face-to-face voltage measurement on the motor bus. So, when we go now to our example, we want to have this application transfer direction from incomer 1 to incomer 2. CB3 is closed. Then we have different possibilities. We can start the manual. We can start by fault start or external start, or via communication, of course. This is also possible when we have integrated protection function, for example. Then these protection functions also start and transfer in case of a pickup of this protection or trip of these protection functions. The transfer directions are freely definable. So that means we can add different applications, and we saw here for such an application we can have up to 6 transfer directions for these 3-breaker application. Okay, so you imagine there is a fault on the main incomer, on incomer 1, and we need to transfer from incomer 1 to incomer 2. By closing the incomer 2 and opening the incomer 1 breaker. And if we have a look here how to do that, then we have to define in a transfer direction in the routing matrix, CB1 needs to be open, CB2 needs to be closed, and CB3 should be closed in that case, that this transfer direction is ready. So, how we test these? Yes, of course, we can test these, but we can test these with a static test, with the Omicron state sequencer, for example, which is part of the Omicron test universe. And for that, you can add 3 different stages. You have the voltage before, you have the voltage in the middle. That means during when the fault has happened, and afterwards. So, and this can be set and can be tested. So that means you can test the transfer, but you have no dynamic. this is without any influence, any behavior of the motor. When the motor is slowing down, the voltage is dropped and so on. There is no possibility for a dynamic testing within state sequencer. So that means such a HSBT function cannot test it only static, so that you can test all these different modes. Therefore, we need to talk about how is the dynamic behavior in case of a connected motor on the bus bar. So, and you see here the behavior in this snail. You see there is some behavior due to opening the breaker 1. That means if we open the breaker 1 in case of a fault on the incomer, then you see there is the red arrow, which is moving in this snail. That means we are far away from the alternative voltage. And that means the frequency, the voltage, and also the phase angle is changing. That means frequency and voltage going down on the motor bus, and also the phase angle gets bigger and bigger between the alternative source and the actual residual voltage on the motor bus. And therefore, we have different possibilities then to transfer the load from incomer 1 to incomer 2. So that means now we have a look here on the dynamics and on the switching types and the different areas. So you see here on the x-axis we have the alternative voltage. We measure the alternative voltage, which is stable, of course, and then the arrow of the residual voltage is moving. That means now we have the first part, which is the purple ones. This is the part of the fast mode. Then we have the light blue part 2 times, which is the part of the real-time fast mode. And last but not least, the light green one is the in-phase mode. In all these areas, we can transfer. But if we are out of these limits, that means part 4, we can't do that because we are in phase opposite, or the voltage is too low, or we have too much transient here in the power supply. And in the end, of course, there's one big requirement. We want to protect the motors for large impact current and also for torsion stress on the motors. And due to that, it is forbidden to transfer in the part or in the area 4. So therefore, we have only these 3 possibilities here to transfer. That means in a fast mode, real-time fast mode, and in-phase mode. That's not the whole truth. We have also the possibility to transfer in the residual voltage or in a long time mode. So that means when the voltage is going under the 70%, for example, then we have no chance to transfer anymore. And we have to wait until the voltage is under 30%, because that if you transfer then the motors or the load on the bus, then the impact torque and the impact current is not so high. So due to that, we have only the part where we can transfer very fast, and then we have the part where have the residual voltage or the long time mode. And both the residual and the long time mode is more or less a backup mode, which is similar to an automatic transfer system. For the other ones, we talk about high-speed transfer system.